Lesson 11, Vector Addition with Components. All right, so in Lesson 10, we were dealing with vectors, one's going that way and one's going this way, and then we'd figure out that the resultant vector was something like that. And we also went over how if you've got a few things that, are going north and a few that are going east and west, we add up all the north-south ones, all the east-west ones, and we end up with a new triangle that we can just make like one single triangle and figure out the resultant of that. That was the second practice problem, if you remember. All right, but now what's going to happen is, what if you have a situation like this, where we've got, A is going east and west, so that's kind of like what we did, but B is off on an angle. So what we're going to do here is, it's a situation like this, right? We got one that's, we like things being east and west or north and south. We don't really like things being on an angle like this. They're kind of harder to describe in physics. So what we're going to do, we've got a different style on here. If I go style 2, we're going to break this second vector into its east and west component here, and its east and west, or north and south component there. You can do that. What we're allowed, like this vector, this red vector here, is the same thing as these two being added together. So what we're going to do is take the components of this red one, and we're going to use those instead, because we like east and south, east and west, north and south. All right, so you do that, and then if you added them together, you can see that our east-west component along the bottom here, that's really just our first vector, the red one here, plus this component of the second vector. And then the north and south is going to be just that one component of that one. And then our resultant vector is the big green arrow here. Hopefully that made sense. I find this thing kind of useful to kind of play around with, to get your mind around what vectors are and how they work. Okay, so I got the same type of thing written here, where we would break up this B vector into its x component and its y component. And then it would be A plus BX would be the bottom of that, and then BY would be the up and down. Okay, moving on. So before we continue, we must learn how to calculate the components of vectors using this as an example. So really, we're back to that SOHCAHTOA stuff, is what we got to do. So what we can do is treat this like a right angle triangle again. And this would be our adjacent side. This would be our opposite side. And what I'm going to do is, maybe just down here a little bit, I'm going to write SOHCAHTOA. My pen's a little off. All right, and now what we're going to do is, let's say that I was looking for the adjacent side first. I'm looking for the x component of this vector. Well, what I do is, again, we got to figure out, okay, which of these three do I want to use? Well, I'm looking for the adjacent, so the adjacent's important to me, and I have the hypotenuse. So which of these three things has the adjacent and the hypotenuse? It's going to be cos, right? So what I'm going to do is start off by writing cosine, and I know the angle this time, so it's going to be cosine 30. Before we were looking for the angle, right? But now we have it. So cosine 30 degrees is equal to, and now it's going to be adjacent over hypotenuse. So the adjacent is what we don't know. So I'm just going to call that, here we're calling it AX, so I'll keep with that. So AX, and that's going to be over 50 meters. That's the hypotenuse. And then we just need to solve for AX. So in this case, I just need to multiply both sides of the equation by 50 meters. So this would look like 50 meters times, I'm going to make a dot for times, cosine 30 degrees is equal to AX. And then that just goes straight into your calculator, 50 times cos 30. And that is 43.3 and positive. So that's 43.3 meters, and it's positive, so it's going to be east. Okay, I just wanted to show you by hand how we got this. I find the SOHCAHTOA thing is helpful. All right, now the only other difference, if we wanted to find the opposite now, is we would have ended up using sine instead, because we want to have the opposite now over the hypotenuse. Pretty much everything's the same, but you're going to end up having 50 times sine 30. You're going to find that a lot, actually. Sine, if you want to memorize this, I'm okay with that. Sine's always going to be the opposite. Cosine's always going to be the adjacent. So if you want to remember it that way, that's great too, or go back to the SOHCAHTOA thing. And that worked out to be 25 meters north if you do 50 times sine 30. All right, so let's look at example number 1 here. It says calculate the east-west and north-south components for the acceleration 25.0 meters per second squared at, now this is the Cartesian method. It's not north of south or anything like that, so it's not the navigator. So this is what you do. You'd end up drawing a little plane like this, a little Cartesian plane. And then this is 215, so that's going to be 30. If you go 215 minus 180, you'd get 35 degrees right there. And now we're good. Now we've got that, and we can just deal with our triangle here. And we want to split it into its x and its y components. We just use SOHCAHTOA like we normally would, and just like we did up top there. So this would end up being AX is going to be 25 times cos 35, because it's looking for the adjacent side, and 25 times sine, because it's looking for the opposite side. All right, now these ones are going to get a little long. They take a little bit longer than a normal question. So this says a man walks 40 meters at 30 degrees north of east, then 70 meters at 60 degrees south of east, and finally 20 meters at 45 degrees north of west. What is the displacement of the man? Okay, so what we need to do for each one of these up here is we need to break it into its components. Oh, my pen's not working. Okay. All right, I think it's working again now. Oh, yeah, okay, good. All right, so we need to break up each one of these into its components. So this is our first one, right? So you go 40 meters at 30 degrees. And just like we did above, if you wanted to figure out the adjacent side, that's going to be times cosine of the angle, and then 40 times that. So that's going to give you this, right? That would end up being a positive number. That means it's going east. The y one ends up going north. So if you want to circle these, we're going to need those in the end. So we want to collect pretty much all of our x and y components. Then look to the next one, 70. And we're going to look down at that and say, okay, if we break that into its x component, you would get 35 meters as positive, so you get east. Actually, and I shouldn't have, I kind of misspoke there. You're not going to really get any like negatives or positives in this thing. You just need to know that it's going to the right, so it's going to be to the east. All right, the y component, it's going to be that. And then looking down in the last one here, so looking at that one, we draw another triangle. We find our y component is that. We find our x component is that. And that's it. We did all that so we could find all the x and y components of each of those triangles. Then what we got to do is we just need to add them all together. So the north and south ones, so all of our y's, so that one, and that one, we're going to just add them all together. So 20 meters north, 60 meters south, so we're subtracting the south, right? This could say minus 60.2, and then plus 14.14 meters north. If you add those together, you get this as a north-south vector. If you add up all the east-west ones, you get this as a east-west vector. Step 3, I know this is long, right? Step 3, now we just use those two vectors that we just found. So this was 26.48 meters south, so that's going to be down, right? So it's going this way, that's here. And then this one was east, so it's going that way. We know that our resultant vector is going to be from there, or from the start to the tip of the last vector. And then we use Pythagorean theorem to find the distance, and then use our trig identities to figure out our angle. And then this ends up being 64.5 degrees east of south. So our answer here is 61.5 meters at 64.5 degrees east of south. So I'm going to end that video there, and I'll do this one practice problem in another video.